This video is for the Phase Change Investigations Lab using dry ice. So if you are completing this by a computer, then you don't need to worry about the safety precautions. If you're doing this in person, you'll need to make sure that you're following the safety rules, which is to not touch the dry ice with your hands. It can cause damage to bare skin, so you may not touch it with your bare skin. Your hands, your mouth, no parts of your body. Okay, so you would sign there. Then it says, procedures and data, dry ice observations. Your teacher will give you a piece of dry ice on a paper towel. Use the metal tweezers on your table to carefully pick up the dry ice and then place it back on the paper towel. Observe the dry ice and make some observations about it. So I have some dry ice here. And then you can use tweezers or tongs to pick it up. Okay. And when I do that, you might hear that squealing sound is from the metal touching the dry ice. Okay. So after it's been sitting on the paper towel, you can pick it up. Again, you can look at it, make some observations about what do you see happening. I'm not touching it, my hand is just underneath so you can see. Okay, so then you're going to describe in words what you see happening and then draw what you see there. Then it says, use the metal tweezers to place a piece of dry ice in a plastic bag and seal the bag closed. Then place a piece of water ice in a different plastic bag and seal it closed. Wait a few minutes and see the difference. Okay, so I'll start with the dry ice one. Put that in the plastic bag, make the air go out, seal it. And then this is water ice. Water ice I can touch with my hand, so it's just ice. Same thing, close it. I can watch for the difference. While I wait for that to happen, I can also take out a piece of the water ice and put it on the paper towel. I do have another piece of dry ice here that I can put on the paper towel so I can kind of look at that while that's happening. And the first thing that I notice right away when I put them on the paper towel is I notice that the water ice one starts making this wet. And that the dry ice one doesn't do that, which makes me wonder, does that have something to do with why it's called dry ice instead of wet ice? Some background information. Water ice is made out of water, right? So it's got H2O molecules. That's the substance that's in here. And so I can see the surface of it is wet and shiny. And like I said, it gets wet, right? So when water ice gets warm, it turns into a liquid. Dry ice, on the other hand, I can see that it's not getting wet. So I've got a solid here, right? And then I can see it's making smoke or steam or vapor. So you can think about what phase of matter is that. So when it gets warm, what's happening to it? Dry ice is made out of carbon dioxide. Carbon dioxide is the same gas that we breathe out. It's also the same gas that's in like soda that makes soda have the bubbles in it. So dry ice or carbon dioxide at in room temperature on planet Earth is naturally a gas. It's got a very, very low freezing temperature. So to get it to turn into a solid, I have to make it be very, very, very cold. And then actually, we see that it doesn't have a liquid state at the pressure that we find on Earth. In order for carbon dioxide to be under, or to be in a liquid state, it needs to be under a lot of pressure. So in like soda factories or somewhere where they want to store carbon dioxide, they might want to store it as a liquid. They have to put it in a tank under pressure for it to be in a liquid state. Okay, so as this is sitting in my bags, I'll notice that these two bags, this one, the water ice one, I'm starting to get some water forming in there, some liquid water. And it's still just as flat as it was before. Now this one is starting to get puffed up because as this dry ice turns to a phase change, you gotta think about what's happening with those particles, right? Those particles turning into a gas, those particles spread apart more than in a solid, right? So it takes up more space in the bag, where this one is still totally flat. Okay, so I can let that continue to sit there, see how that progresses. And then I can fill out this paper. So it says, wait a few minutes, compare the two bags. What is similar and what is different? Well, so they both definitely still have a solid in them. They're not, neither of them is empty. Did you observe a phase change? So yes or no, and then explain how do you know. Then it says, use the metal tweezers to place a piece of dry ice into a beaker of water. Observe the dry ice and make some observations about it. Okay, so I have a beaker of water. And I'm gonna use a little piece at first. So again, do you hear that sound? Terrible sound. Okay. Ooh. So I can see what's happening there. So as this creates bubbles, you can see the bubbles are actually filled with that white carbon dioxide. So it's bubbling. Usually when we think of water bubbling, we think of it as being really hot. But this, if I touch it, it's cold. And this steam is actually cold as well. So the steam is safe to touch. This is carbon dioxide gas. This carbon dioxide gas is also more dense than the rest of the air, so I can pour it. And see how it goes down like that? Because it's more dense. Again, I can touch it, and it feels kind of cool. It's not very cold, but it's just a little bit cool, cooler than the rest of the air. Okay, so I'm going to then draw that picture and just write the description of what I see. Then it says, what causes dry ice to change in phase? You'd think about what causes any phase change to happen. And it says, draw and label to show the molecules before and after the phase change took place. So here, we're gonna draw the molecules in that solid phase. And then in the after, I would draw it in this gas phase. What do those molecules look like? If I could zoom in and see those molecules, what would those molecules look like? And then I can see, now that I've let these bags sit there for a while, you see this one is really, really inflated because this is continuing to turn into a gas, and this one is continuing to turn into a liquid. So I can see there's maybe just a little bit of liquid in there. Okay. And then it says, the last one, suppose you wanted to design an experiment to figure out how quickly dry ice sublimates in hot water compared to cold water. Think about what steps you'd need to follow, write the materials and the procedure for the experiment. So think about what kind of materials you'd need and what you would need to do to figure that out. Okay? So it used the word sublimates. Sublimates means like sublimation. And if you remember from our lesson on phase change, sublimation means when it goes directly from a solid to a gas. So that is what's happening here, right? It's going from a solid directly to a gas. Should we do that one more time just for fun? Okay. So go ahead and finish your worksheet. And that's the lab.